In this section, we're going to solve quadratic equations with the square root property. But first, let's review the form for a quadratic equation. You're going to have your equals, of course, and you're going to have something squared. So this is our standard form. We'll get 0 on one side. The first method of solving that we learned was to use the zero product law, which says if you have a product on one side and 0 on the other, then one of those pieces of the product must be 0. So if you can factor and get that product, then you're able to solve that way. So for problems that are easy to factor, you should use that technique. This one is an easy trinomial. You can break it down. Like signs both plus, split your x's. We're multiplying to get 12, combining to get 8. How about 6 and 2? Double check, 2x plus 6x, that equals 8x. And then we can solve. This is A, this is B. So either this one equals 0, or the x plus 2 equals 0. Subtract a 6, subtract a 2, and it is solved. So if it is a simple problem to factor, that is the technique to use. Sometimes we will have problems that will not factor, and we need some other techniques to solve these equations. This is an example of one that will not factor. If it was minus, you could do difference of squares, but with plus, you cannot factor it. Let's use the definition of square root to solve the following problem. To undo the square, we will take the square root of both sides. So we'll take the square root and the square root. And it gives us x equals, we get two solutions over here because we had a variable, and if there are no restrictions, your definition says the square root of a variable squared is the absolute value of x. So we're not told that x is always positive. So x could be anything here. So we're going to get two solutions. We will get plus and minus the square root of 9, plus and minus 3, because positive 3 squared is 9, and negative 3 squared is 9. So we can take the square root of both sides, but keep in mind we will get two solutions with this technique, plus and minus. The time when the square root method is a good choice for solving a quadratic equation is when you have something squared on one side equals a constant. For our next equation, we do have a quadratic equation. There's your equals. Here's your exponent of 2. This is a perfect setup for square root method. You have something squared. You don't have a plain x term, so something squared equals a constant. Take the square root of both sides. When you take the square root on the left, you're going to get just x equals plus or minus the square root of 12. Now, if the radical will simplify, you need to simplify. This one does have a square in it. It has a 4. So we can break down. You can go all the way to primes, or if you see your 4 there, you can take your square root there. Right, so we can take a 2 out. X equals plus or minus 2 times the square root of 3. Let's look at another problem. So our next one, we have x squared equals 81. It's a quadratic equation. We have an equals, we have an exponent of 2. We have x squared equals some constant. So x will equal plus or minus square root of 81. 81 is a perfect square. The square root of 81 is 9. For the next problem, it is a quadratic equation. It has the x squared. It is missing the x term. So we have x squared and we have a constant. This is the proper kind for square root method. You need to isolate your square term. So we need to get the 24 off. We're going to add a 24 to both sides. and that will give us x squared equals 24. Now we have x squared equals some constant. Then take your square root method. So x equals plus or minus square root of 24. We may need to simplify that radical. There is at least a 4 in there. So we will break down. So we can do 4 times 6. And there's some 2's and a 2 times 3. So a 4 is all we can take out. So we'll take out a 2 for that square root of 4. So plus or minus 2 times the square root, put those back together, of 6. So x equals plus or minus 2 times the square root of 6. Our next problem, x squared equals negative 49. It is the proper form for the square root method. Something squared equals some constant. Take the square root of both sides. So x equals plus or minus square root of negative 49. Remember, if you have a negative under the square root, that is going to be an imaginary number. So you can take out your I for that negative. Also, 49 is a perfect square. So this is going to be 7i. So x equals plus or minus 7i. The next few problems look a little bit more complicated, but if you look close, it is something squared equals a constant. So you can use this technique. Right, so we'll take the square root on the left, and that will leave x minus 3 equals plus or minus the square root of 5. Now, you need to isolate your x. So you're going to add your 3 to both sides. Add it in front of your plus and minus, so it will pick up both of those. So our solutions are 3 plus square root of 5 and 3 minus square root of 5. You will leave it there. Our next problem is also something squared equals a constant. So we'll take the square root of both sides. On the left, it will leave us 2x minus 5. On the right, we will get plus or minus the square root of 18. Let's go ahead and simplify on that side. So 18 has a 9 in it, 9 times 2, and 9 is a perfect square. You can take that square root, take your 3 out. So this is plus or minus 3 times the square root of 2. So we have 2x minus 5 equals this. Add your 5 to both sides, so 2x equals 5 plus or minus 3 times the square root of 2. And you still have to isolate your x. So now divide out your 2, and it will just leave x equals 5 plus or minus 3 times the square root of 2 over 2. You cannot simplify the 2 with anything. You can't go from here underneath the radical. So leave it just like this. Our next problem looks even a little more complicated, but we do have something squared and we have a constant. So let's go ahead and get the 20 on the other side. So we have y plus 4 squared equals will be a negative 20. We will take the square root of both sides. It will be y plus 4 equals plus or minus the square root of negative 20. Let's simplify that radical. So for our square root of negative 1, that's going to be an I. So we're going to have an I there. I'm just going to write this on the side. So there's my I that I'm going to pull out. Right, from the 20, I have 4 times 5, and 4 will give me some 2's and a 5. So I can take a 2. Right, so I have plus or minus 2i times the square root of 5. And now I can isolate my y. So I will subtract my 4 from both sides. I'm going to do it in front of the plus and minus. So it will go with each one. So y equals negative 4 plus or minus 2i times the square root of 5. Let's try another problem. We have something squared equals a constant. So take your square root of both sides. It will leave us x minus 4 equals plus or minus square root of negative 16. 16 is a perfect square. This one also has that square root of negative 1, or the I. So this will simplify to 4i. We will add this 4 to both sides. So x equals 4 plus or minus 4i. We have one more problem to look at. We do have something squared. We have a constant over here. So let's move this 9. We'll add a 9 to both sides. That will leave us 4x minus 1 squared. 9 plus 7 is 16. We will take the square root of both sides to leave 4x minus 1 equals plus or minus the square root of 16. 16 is a perfect square. It is 4. So we have 4x minus 1 equals plus or minus 4. We will add the 1 to both sides. 4x equals 1 plus or minus 4. And we will divide by 4. So x equals 1 plus or minus 4 divided by 4. Simplify these. So first with the plus, 1 plus 4 is 5 divided by 4. So one solution is 5/4. And the other is 1 minus 4, which gives us a negative 3/4. Right, and I really should put those in numerical order. Negative 3/4 and 5/4 are our solutions.